Elliot.
Hope everyone's recovered from their food comas and their bruises from Black Friday, because this is Miss Miller's Math Show with the co-host, Crystal.
There we go. I was not supposed to hit a button at all. Okay, here we go. I also had a week off. My brain is still not quite here yet. All right, so here we go, you guys. Before we get into today's lesson, and I should tell you ahead of time, today's lesson is one example, and one example only. Let's hear a round of applause for that. That is the lesson for today. We are going to just really quickly review, since I know you all have had a week off for Thanksgiving break, we're going to review what we did before break. So, simplifying rational expressions, like the one we have here, x squared plus 7x plus 12 over x plus 4. Remember what we would do is we would factor the numerator, factor the denominator, and then cancel out things that match. Sloan? Cool. I agree. Everybody give it up for Sloan. Okay? You want to fill in the diamond too? No. Okay, that's good. Cole, you want to? Go ahead. Good? Good? 4 and 3, excellent. And what goes on top of the 4 and the 3? X. Where do we get the X? The X squared is evenly distributed. I hope this is ringing bells for people in some way. Okay, so then what does this look like totally factored? Zach?
It should look like x plus 4 and x plus 3 parentheses.
Cool, and then we have an x plus 4 on the bottom. Everybody give it up for Cole and Zach. Okay, then we are canceling out anything that matches. Liz? The x plus 4s. So you only have x plus 3. Everybody give it up for Liz. And the end of that problem. All right, next one. Next warm-up problem is multiplication. So we have x squared plus 4x plus 3 over x squared minus 1 times x squared minus 2x plus 1 over x plus 3. So does anybody see anything that can be factored here? Any numerator or denominator that can be factored in any way? Michael? Cool. Everybody give it up for Michael. All right. Who wants to fill in the diamond for me with x squared plus 4x plus 3? Aiden. Good? Cool. Excellent. Everybody give it up for Aiden. That was sad. Everybody give it up for Aiden. All right. So two numbers that multiply to 3 that also add up to 4. Alan. Other way around. They multiply to 3 and add up to 4. That's good. Everybody give it up for Alan. All right. What goes on the top of each of the 3 and the 1? X, because we're splitting up this x squared into either of those. Okay, so we get x plus 3 and x plus 1. Oops, I should have made that a little longer. There we go. Okay. What else? Anything else that can be factored? Nothing? We're all done? Zach?
Maybe the other one could be... Are we just focusing on the first equation right now?
We're focusing on either this new... Well, we just did that one. Or this, or this, or that. We have 3 left that may or may not be.
Maybe do the box method, the diamond method with the other one.
This one?
On the top, yeah.
Cool. Okay, when we do that, Zach, what goes in the top?
The top, 1 goes on the top.
Good.
Maybe 2 goes on the bottom.
Cool. Okay, everybody give it up for Zach.
Yay!
All right, two numbers that multiply to 1 and add up to -2. Aiden? -1, -1, also known as what? -1 squared or a perfect square trinomial. Cool. Everybody give it up for Aiden. Okay, when we multiply something by itself, that is the same thing as the thing itself squared. So that's x minus 1 squared. Okay, we have x squared minus 1 when we have x plus 3. What do we think? Michael? Perfect. Everybody give it up for Michael. So he said x squared minus 1 is the difference of two squares. Michael, do you remember how that factors? Cool. How does it factor? All right. Everybody give it up for Michael again. Okay. How about x plus 3? Anything that we can do with that? No. Let's leave it like that. So let me write a little bit neater down here what we're left with. We have x plus 3, x plus 1, x plus 1, x minus 1 times x minus 1 squared over x plus 3. Okay, so anything that can cancel out? Sloan? All right, cool. Everybody give it up for Sloan. X plus 1s. Liz? Cool. Everybody give it up for Liz. X plus 3. That was sad. Everybody give it up for Liz. X plus 3. There we go. Much better. Aiden? Good. One of the x minus 1s. There are two on top and one on the bottom, so we end up with one left over. So who can tell me what the final answer is? Sloan?
X minus 1.
X minus 1. Cool. Everybody give it up for Aiden and Sloan and everybody else. Woo! All right. Questions on this? Review? Yes?
Yes.
Okay. So this is how easy what we're doing today is. There is one small difference between what this problem was and today. How many people clap if you had Mrs. Barnett for Algebra 1? Okay, does anybody remember she had a little saying that she did when dividing fractions? Anybody remember what that is? The saying, Zach?
Wait, is it the oh goody goody?
No, that's a little different.
Same change.
There we go. Good. Same, change, flip. Everybody give it up for Sloan. And Mrs. Barnett. Okay. Woo! What exactly does that mean? Same, change, flip. And how do we apply it to this problem? Olivia.
Repeat the first term, I guess.
Uh-huh.
The same.
Good.
Then you change the sign in the equation, and then you flip the fractions.
Perfect. Everybody give it up for Olivia. Okay, super sad. Everybody give it up for Olivia. We all need to be jump-started today. How many people clap if you are sort of still on break? You're not quite back yet.
Well, actually, no.
Okay.
I like between irritated and getting on task. Like, that's where
Between irritated and getting... What is it that's irritating you?
like that I have to go back home and then I have to
Do homework.
try to go to sleep after I do homework.
I know.
Then
I
there's
know.
on task where I have to do it.
Just like think of it as like us having a little temper tantrum right now.
Yeah. like,
How fun for me that you all are having temper tantrums right now. All right, so we keep the first fraction the same, unless you're talking math, which I doubt you are. Gentlemen, pay attention. Shh. X plus 3 over x plus 2, that stays the same. Like Olivia said, the division sign changes to a multiplication sign. And then we flip meaning the top becomes the bottom and the bottom becomes the top, the second fraction. So this becomes x squared plus 4x plus 4 over x squared minus 9. And now we're back to the same exact thing we were doing. So everybody be looking for things that can be factored within each numerator and denominator. So, anybody see anything that can be factored? We have x plus 3 over x plus 2. That's the first fraction. And then we have x squared plus 4x plus 4 over x squared minus 9. So, Samantha. Good, what is that? Cool, everybody give it up for Samantha. Okay? Samantha, you remember how that factors?
Oh, x plus 3.
X plus 3, x minus 3. Okay, everybody be looking for what we can factor next. Mrs. Miller. Okay. 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 Okay, let me break these down. Okay. Okay, okay. Uh-huh. Okay. 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 Got it. Thanks. All right. I can get that afterwards. That was quite a list. Okay, here we go. Anything else that can be factored? Aiden. Good. What is that? Okay, we could do the diamond. Ah, perfect. All right, everybody give it up for Aiden. He said
answer.
How about everybody give it up for Aiden? Then I will tell you what he said. He said that this is a perfect square trinomial. And, Aiden, do you remember how that factors?
Would it be x plus 2 squared?
Perfect. Everybody give it up for Aiden again. Plus 2 squared. Okay, x plus 3 over x plus 2. Nothing. Cool. Everybody leave it the same. All right, now we're looking for things that cancel out. Zach.
Cancel one of the 2x squared, one of those 2 x's,
Okay.
and then the other, and then cancel out 3 plus x.
X plus, all right, perfect.
Plus 3 for that.
Okay. Everybody give it up for Zach. What are we left with? Liz. X plus 2 over x minus 3. Everybody give it up for Liz. Okay, now, if we're doing the same thing we've been doing this whole time, I see some x's that match. So I can cross the x's out and I'm left with 2 over... No, why not? Somebody convince me. Because I keep seeing we're crossing stuff out that matches, and the x's look like they match to me. So why am I not able to do that? Liz? Ah, okay, good. It's like there are invisible parentheses here. And then they technically don't match anymore. Cool, everybody give it up for Liz. So that is our answer. Any questions? I have 6 people. 6 people. That was that phone call. In the meantime, send us off, everybody.